Now we are going to discuss about project level assessment of environmental impact. So the author was trying to tackle mainly two problems here. One is how to associate a cost to a particular resource, and how to provide incentive to those companies which has incorporated these conservative measures. There are some natural resource for which we can directly say that the cost is this much. Say for example, a timber or a fish which has some market value, we can say that the environmental cost for these and these resources are this much. But there are some other natural resource for which we can't associate a particular value. Say for example, soil. Soil acts as a filtrant. Like water percolates through it, it removes suspended particles. So it acts as a service there, but we can't really associate a particular cost for that. So the author will try to see how to associate a cost for this kind of services, and how to incorporate this ecological conservative measures into the financial statement, and thereby providing incentives. So as I point out, assigning a market value to all resources is difficult, like the soil example that I have given. So the author comes up with a framework which consists of 4 components. One is quantifying the project level emissions and effects. Next is assessing the ecosystem service and functions. Third one is valuation using functional substitutability and influencing decision making process. So before going into the cost associated with the resources, we need to find out what will be the impact of a project on the environment. So the first step will be quantifying the emissions. This LCI stands for life cycle inventory. So the basic tools used in this quantifying emissions will be the industrial ecology and life cycle assessment. Industrial ecology is nothing but the interactions or relations the industry has with the environment, and the life cycle assessment is a technique for determining the effects. So once we determine the effects of a particular project, we can associate a particular cost for that. So input for a life cycle assessment will be land, labor, capital, etc., and the output, which is the life cycle inventory, will be the products, pollutants, and the solid waste. So next one will be assessing the ecosystem service and functions. So a ecosystem function is a natural process, and ecosystem services is the benefit humans get through that. Say for example, the decomposition of organic matter. This is a process which happens with or without the human interference. So this is an example of ecosystem functions, and through the decomposition we are actually fertilizing the soil, and that's a benefit. So this comes under ecosystem services. So when we are saying that we are assigning environmental cost to the natural resources, we are actually dealing with the ecosystem services and not the functions. So ecosystem services constitute the natural capital and are the basis by which humans have provided value from natural ecosystem. So the third one will be the functional substitutability, and the final will be the influence decision making. So once we said that the impact of a project will be this and this, so we have to find out the cost associated with that particular destruction or degradation. So say for example, there is a project and it has a particular impact on this. So we are losing that particular service from the nature. So what the author is suggesting is that we need to come up with an engineering system, a man-made system which will serve the same purpose as the natural component, and the cost for that engineering system will be the environmental cost for that resources. And the influential decision making means we have to incorporate that particular cost into the balance sheet, as Sir mentioned out, so that the company will be getting some incentive for that. So author was giving an example of an hypothetical theme park in China. So the design decision concept was the surface parking. So the first thing was quantifying the emissions. So they were having 2 alternatives. One was either to go for an hot mix asphalt pavement or for a porous pavement surface. So the first thing will be quantifying the effect. So if you go for a hot mix asphalt, it is impervious, which does not allow water to percolate. So that's an issue. Second one is porous pavement, which allows water to go through that. So the second one will be assessing the ecosystem services. So basically, if we don't allow water to go through it, actually water goes through the soil, it reaches the groundwater table. Water acts as a natural filtrant, removes the suspended particles. So that ecosystem service is getting affected here. That will be the second one, assessing the ecosystem services. Now third one will be finding a substitute for that, an actual substitute for that. So the service which is getting affected, that is removing the suspended particles, we come up with an engineering system which is nothing but a water treatment plant. So the cost for water treatment plant, maintenance, installation cost, all those sums up, makes the environmental cost for that particular parameter. So like the ecological function affected was the removal of suspended particles, identical engineering system was a water treatment plant. So here they were mentioning that the cost for hot mix asphalt design was around 8,97,000 Chinese unit, and for porous system around it was around 9,67,000. Now considering the cost of water treatment at 1,06,000, we can subtract this cost from the porous system, and this can be included in the financial statement, which can be an incentive for the companies. So this was a mechanism suggested by the author for providing incentives and for finding the environmental costs associated with natural resources.
Yeah, so I hope you guys understood this method, right, and how this sort of works. So it's essentially, we start off by saying the action that you're doing, what kind of services or ecosystem services is it impacting. So in this case, if I'm laying any concrete road or asphalt road in this case, there are a number of things that are happening. One, very clearly in many cases, you might be affecting percolation of water into the ground, and therefore you have a groundwater table impact. You might also, if you have too much of impervious surface, there is too much of runoff from the rains, and that might increase your chances of flooding, right, because all of that water, particularly if you have a heavy rainfall event, all of that water has no place to go because you've got an impervious surface and it runs over. In this particular case, an additional issue is the suspended solids, right, or the dissolved solids in the water, which continue to stay in the water, right, instead of because the sand acts, or the road, or the soil acts as a natural filter. So when you take all of this water and it rains and it percolates into the aquifer below, there's a lot of natural filtration that happens that makes the water in the aquifer relatively clean, right. So by building an asphalt road and the water is running off, no one is doing that cleaning of my water, right, that natural filtration is sort of not happening. So the point is, by building a hot mix asphalt road, right, I am creating some negative effects, right, and to illustrate, they've taken one negative effect, which is the suspension of the solid particles, or the removal of the solid particles, which is not happening, right, which means wherever this is going to, like let's say it's going to a nearby lake, right, that lake is now going to have water which has these suspended particles, right. So therefore there is an environmental harm that you're doing by building this. So like I said, there are many environmental harms. Purposes of illustration, they've taken one, okay, and essentially what they're asking is, what is the cost of that harm, okay. Earlier there was something called the contingent valuation mechanism, right, and a very simple way of looking at the contingent valuation mechanism is to almost to ask you the question saying, how much would you pay me to not have this system in your backyard, okay. And if I ask that to a number of people, or not ask you that question, but to say, if would you pay me 500 crores not to have this system in your backyard, and you might say, wow, that's too much, right. Would you pay me 5 crores not to have that system in your backyard? Maybe that's still too much. Would you pay me 25 lakhs not to have this system in your backyard, right, and you might start thinking about it. Would you pay me 5 lakhs not to have this system in your backyard? And you might say, yeah, sure, I'd pay you 5 lakhs not to have this system in your backyard. And so there's a way in which I can constantly ask you to understand what your value point is, right. So that's sort of a caricatured way of understanding what was called contingent valuation. That's one way of valuing it, right, is to just look at your perception of you're going to get muddy water in the lake, okay, as a result of the hot mix asphalt payment. How much would you pay me to take that problem away from you, right? But what these guys are talking about is saying, look, we don't need to be that qualitative, we can be quantitative. We can sort of say, if you built the hot mix asphalt road and you put all of that water into the lake, then in order to have the same quality of water in your neighborhood, you would have to build a treatment plant, okay. So the treatment plant that would then treat the water so that it's the same quality as the groundwater, right, after the natural filtration and percolation, according to them costs 106,000 RMB, Chinese currency, okay. So in other words, right, the natural system is adding a value of 106,000 RMB. That is the value that you're losing by putting in the asphalt payment, and so you have to spend another 106,000 RMB in order to create that value back in your system. In order to get that pure water back, I have to spend another 106,000 RMB, right. So I can account for it in both ways, right. So as they say here, if I can, or maybe I can just do it on my slides because I'm already marking them up. Alright, so here's the thing. So if I just did a pure economic analysis, right, the hot mix asphalt only costs 896, that's the net present value, the net present cost, okay. Whereas the porous payment essentially would cost me 967,000 to put all of those layers, etc., etc. So if I just looked at it economically, right, and I just want a parking structure, right, I want a somewhat solid surface for people to put their cars on, right, it's clear that I should go with the asphalt, it's cheaper, okay. But now when I add this service, right, I also understand that this system also is delivering a service to me, right. It is also cleaning up the water, right, that's filtering down, it is taking away the suspended solids, right. And the value of that system through the principle of substitutability, right, is 106,000 RMB, right. I've created 106,000 RMB of value, that's naturally created, because otherwise I have to artificially create it by putting in that Storm Scepter 450i or whatever that system is, and that costs me 106,000, right. So either I can say I want to add 106,000 to this cost, because really, you know, I can't just put the road, I have to put the road and the treatment plant, okay. Or I can say this is now creating a value of 106,000 crores, and generally I like to look at it in terms of ecosystem functions and values, right. Saying the cost of this project, you may not put in the treatment plant, right, you might just put the road and walk away, right. So this is the cost of the project if you do it this way. If you do it this way, you're spending 967,000, but you're also getting included in it the benefit of 106,000 because it's performing that function also, right, and therefore it's only 861,000. Now I'm comparing 861,000 versus 897,000. Now 861,000 is a better deal, right, than 897,000 from a, because these are costs, right. So the cost, overall cost is 860,000. Now if I add on the groundwater recharge, right, and figure out a substitutability for that, right, and I say things like, okay, we are dependent on groundwater for water, right. So either, I mean, I can just put a bore well and take out water at 10 rupees a kiloliter versus buying water from you know, a private water operator, right, which is what I'd have to do, because otherwise I have muddy water in the lake, I can't really drink it, and that might be 25 rupees a kiloliter. Then I'm also adding an extra value of 15 rupees a kiloliter through the porous payment, right, because I'm actually able to draw fresh water from the ground, and I can sort of quantify that and add that as another benefit, right. So I can put in, and then if we look at, okay, once in 25 years we are going to have heavy flooding, right, because of the asphalt payment which just pushes water here and there, and the loss to property from flooding, right, because I mean, if you're flooded, your car is not operational because it's been underwater, your furniture has been trashed because your entire ground floor is underwater. So you can sort of say all of that is money lost, okay, and that is therefore money that I save by building in the porous payment, because I'm reducing the incidence of that flood. So I can start thinking about creative ways of trying to put numbers onto these environmental impacts, right, and it could be, and it doesn't necessarily just have to be water and solids, right. I can do the same thing with, so for instance, I take away somebody's agricultural land. Yeah, Zamil, you had a point? Okay. So I am sort of going to build something which takes away someone's agricultural land, okay. How would I use this principle to arrive at a cost on that? What's a way in which I could arrive at a cost on agricultural land? Perfect, right. So yeah, so what I can do is I can sort of say, look, if this sort of green space was out there, let's not just call it a farm area, right, farm, forest, whatever, then this area would have sequestered this amount of carbon. That's a service that it was providing, okay. Now that that service is gone, right, my CO2 levels are likely to be higher, and therefore, right, the logic would be that I could then buy some kind of air purification machinery or some carbon sequestration machinery to arrive at the same air quality that I would have had beforehand, and that might cost me, I don't know, 10 lakhs, 15 lakhs, whatever, because now the second part, the machinery, I can find the cost from the market, right. So if I have a particular, you know, air purifier, Air OK, IIT Madras incubated companies, air purifier is what I want to buy, I can go to the Air OK guys and ask them what it costs, and that's what I end up saving. So now I sort of say that by continuing to keep this as farmland, right, I would have had an extra benefit of X which I am now losing. right? So put it on one of your balance sheets. No, so okay, so the question is on the practical applicability of this, right? So at the moment it's still not being applied, right? So where this research is heading, right? So this is a paper by a gentleman called Mike Lepech who teaches at Stanford, and what he is trying to do in some sense is to influence accounting standards, right? So there's something called GAAP that some of you might be familiar with, GAAP. It stands for Generally Accepted Accounting Principles, right? So that tells you how should you account for various things, right? So as a chartered accountant, right, when I prepare a company's balance sheet, etc., I have to conform to certain generally accepted accounting principles. So is this an expense? What category of expense does this come under? Can this be depreciated? There are certain rules, right? So the idea is, can I put this thinking also into that generally accepted accounting principles, so that when I do project accounting, which is essentially what I'm doing, right, it's clear that this has to be done, that all of these effects in this manner have to be factored in. Then you will actually find some debate on what goes in and what goes out. At the moment, this is still in the research realm, right, where people are saying, look, these are ways in which we do this, right. So the objection to this, for instance, is that we've done this for just one issue, which is the suspended solid question, the dissolved solid, suspended solid question, right. But there are so many other, and this was easy because I could find an analogous water treatment plant, right. But if I really sit and think of all the environmental effects, flooding, groundwater recharge, whatever else, right. First of all, it might be difficult to make an exhaustive list. All of them may not be as easy to evaluate as this example. So the practical, you have to really build a huge database, right, a huge matrix in some sense of the potential things to consider, right, when you're laying roads, when you're building a power plant, etc., and ways in which you consider them. So it isn't practically applied straight away, but the principles, but this is the thinking that I think we need to head towards, right. I think this is what we need to start doing to projects going forward. We've got to sort of not only look at the NPV, we also have to look at the ecosystem services that we are adding or destroying, right, put them in and then decide how good this project is. And in that way, the theory is we would automatically minimize all of these issues from stakeholders, etc., because we've actually taken their systems into consideration and put them on the balance sheet, and therefore it's no longer discretionary. Then banks can say, I will not fund because I'm following equator principles. I will fund projects where this accounting system is used and I come up with an IRR of 10%, right. So I want you to use this accounting system, come up with an IRR of 10%, then I'll fund it, right. That makes it much less objectionable as opposed to saying, yeah, you said you have a charter, equator principles, but we are not sure how robust they are, who's going to monitor, etc. So the question essentially is, okay, fine, it goes back to the same thing, dissolved solids, that's an easy question. I lose a temple which is sort of, or the spirit in the waterfall in the Burjagali dam project. How do I sort of put a value on that? What's the substitutability that I could? So two responses to that. One is clearly there are limitations, right? There are certain things that you might just not be able to put on a balance sheet, okay? But on that point, the view is still that fine, just because you can't put in certain things, don't throw the entire methodology out of the window, right? So there are certain things that you can put in. Let's put those in and at least have, a double bottom line accounting system, if not a completely triple bottom line accounting system. But let's certainly understand that there may be limitations. Second is, and this is where sort of research, continually brings out surprises, is sometimes the limitations are a bit further than we think, right? So social perception to some extent can be valued, and in the whole literature on risk analysis and risk management, people have come up with interesting ways of quantifying some social perceptions towards certain risks, not necessarily heritage structures and something sort of deep seated, but other preferences as well. So I think the limits to what we can put on these balance sheets, what we can quantify, might be a little bit further than what we think, but I agree that I'm not quite convinced that every human emotion ecosystem function can be condensed into this. I mean, the argument has always been, even if you destroy an acre of wetland, right, it doesn't matter if you build 10 acres of new wetland elsewhere. Nature has evolved an interconnected series of functions over so many millions of years that you will never be able to physically recreate it, and therefore there's no way of saying, oh, this is what it would cost me, right, because it's impossible to do, right. So therefore there are limitations clearly to this, but again it goes down to sort of saying, it's not just doing good stakeholder analysis, transparent discussions and convincing NGOs. You've got to convince governments and project sponsors and financiers to pick projects that have low environmental impact, social impact, but high economic returns, and at least have them go through a process of putting in certain safeguards, right. So, we need sort of banks and others to sort of subscribe to some prescription, so that you actually have some control. You can be completely qualitative like the Equator Principles, just sign on to do no harm, or maybe make it a little bit more detailed, come up with a process, or it can go all the way towards actually coming up with methods of quantifying impact. And there is a large literature on socio-economic cost benefit analysis. Some time ago, I do not know if it is still online, Asian Development Bank even had a handbook that was online on how you would actually measure these kinds of the kinds of impact that would be lost. Even things like if I take away some acres of farmland, then I am taking away the productive capacity of that farmland from now till infinity, and if I were growing apples there, I can figure out how many apples I would grow per year, what I would make per year, and therefore the amount of revenue I would be losing in perpetuity, right, giving away that farmland for a road being built, right. I can take that as a cost and put it on my balance sheet. So, I think we really need to start thinking of the environmental impacts, costing them, putting them on balance sheets, and then making decisions based on the economic and environmental value, but both quantified, right, not one quantitative, one qualitative. Then I think you will have banks and sponsors and governments and large developers making more environmentally conscious decisions on projects, right, and hopefully you will minimize protests, etc. going forward. The question on CSR is, so CSR is an investment, corporate social responsibility is an investment made by companies, right. Now, what we are trying to sort of say is, okay, that is your cost, okay, what is the benefit, what is the impact, what is the ecosystem service, right, that you are taking away or delivering, right, because of this, okay. So, yeah, like I said, I created an Anganwadi, I created a school, I can tell you how much it cost me because that is a bill of materials. What is the impact that I have created as a result of that is, and therefore, if I can say this is the kind of impact that I have created, then I can use the principle of substitutability somewhere, right. I can tell people that by destroying certain livelihoods, so this project is likely to destroy certain livelihoods. In order to bring those livelihoods back, you would need to build this kind of an Anganwadi, right, and that would cost so much, right, and therefore the cost to you of destroying livelihoods through building a road through this community can be equated to be this cost of that Anganwadi, which came through a corporate social responsibility function. But I think CSR per se is just what that's amount of money I spend. I think what we are talking about is what is the ecosystem function, right, or the ecosystem service that you are delivering, and therefore can I value it, right. If I agree that this is the value, then what you spent as CSR will be the cost of that, and then I will sort of put it in, right. So, this is very cutting edge, right. So, these are ripe topics for term papers, this is a ripe topic for potentially dual degree projects and MTech projects or whatnot, etc., to try to see how do we push the envelope further, how do we use this practically, right. Can we do something like this in India or an IIT or whatever? Yeah, couple of questions and then we will stop. Aman. Good question, okay. So, I am assuming 106,000 rupees or RMB of water treatment. What if that number changes going forward, right? Therefore, would I have miscalculated, right? Maybe in 2 years this is only 50,000. So, maybe I should have then reduced only 50,000. So, that tells you some of the issues of valuing this based on these kinds of methods. I would assume the value of removing dissolved solids should not really change, right, but clearly it changes based on time, based on the method you use, etc. So, I think those are limitations, right. So, we will have to sort of figure out maybe this is not a one time thing, right. Maybe for instance, in this case the authors would argue, right, that plant would also have a recurring operations maintenance cost that might come down because of technological advances. So, do not take it as one single cash flow, take it as a stream of cash flows and have some changes over time, right. Yeah. So, therefore, in 5 years when I did the life cycle calculation for the storm scepter thing, right, and many of you have been in my class when we have done economic analysis, we talk about replacement every 6 years, 9 years, 10 years, right. When we assume that we replace with the same asset, right, you assume that you replace with an asset that is going to be much cheaper and you do the economic calculation. So, still it is doable, but you are right, it is a little bit more complex. So, so this is just an example of one calculation, right. So, porous payments have a bunch of ecosystem services that they are delivering, possibly some ecosystem services that they are not delivering. Hot mix asphalt, again, this is one ecosystem service that hot mix asphalt is not delivering, right, but they may be delivering other services. So, for instance, if you are actually saying I would not want to take groundwater, right, I want to actually channel water into the lake and take that water, then that is a service that this hot mix asphalt is actually delivering, right? Maybe it is cheaper for me to pump water and purify water and pump it out of the lake than each of us installing our own RO systems, right? So you're right. So this is just an illustration, but that also, your question also tell us how complex this whole thing is, right? Even for a simple thing as a parking lot, if I'm getting into so much debate, when I build a dam or a road or an airport, right, look at the number of things that I'll have to sort of consider, the number of options, the number of benefits, the number of disbenefits, right? So it's massive, okay? But baby steps, right? We need to sort of at least come to say, these are certain major impacts that we need to take into account, right? Let's put these on the balance sheet, right? So we need to start, I think, thinking in that direction. So this is very, very new. Nobody is doing it today practically, right? But I think 10, 20, 30 years out, if climate change is going to be as predicted, right? And I believe climate change is going to have significant impacts. Unless we really start thinking environmentally and socially about projects in a very rigorous way, I think we are in deep trouble. And the only way to really think about it rigorously, I feel, is to bring it into the balance sheet. Otherwise, it's just you versus me, qualitative, depends on the committee, who's on that committee, how favorable are they to this, too many unknowns, right? As it is, there's a lot of criticism that many environmental clearances are being given because the committee is not doing enough, these committees are not doing enough scrutiny. The committees will say, no, they've met some basic parameters, and it's just a qualitative argument, right? So we need to move in these directions. Obviously, it's difficult today to envisage how we would change, but that's the role of research and innovation and all of that, right? So I think this is to me, I'm very convinced that this is the way forward. To build infrastructure better, we better understand this better, and we better start figuring out ways to apply it on projects. So another way of doing it is to say, the water treatment plant costs 106,000, but it provides other services as well beyond just the TDS removal, okay? So now that's a benefit that the water treatment plant is giving you, right? Which you now add on to which you now subtract from the hot mix asphalt side of the question, right? So this is where you've got to be very clear. So we've taken one narrow example to illustrate the method, is what Mike and Ben Schwegler and others have done in this paper, okay? But you're right, I mean, so I hope you guys are able to appreciate that just even such a simple thing you guys are coming along with. There could be other technologies, there could be other benefits, disbenefits, etc. So it's not easy just to sit down and list. If you brainstorm, more and more ideas will come out, right? Just with the simple porous versus hot mix asphalt example, and which is why I'm saying when I scale this up to an airport, right, that starts probably getting out of hand, and that's why we need standards, right? We need to be able to say, these are the main ecosystem services and functions that you should include in the balance sheet, right? There may be other ecosystem services and functions as well, but we've decided because they are not that critical that we will not include them, right? So we look at water quality, we look at marine life, we look at certain categories. For those categories, these are the methodologies that you adopt to evaluate them. These are the substitutable elements, right? So we need to come up with guidelines and then insist that accounting standards take them over, so that every project, irrespective of whether you're doing it or I'm doing it or this is the committee, we follow these patterns and we come up finally with a IRR, NPV, whatever. And that is the basis on which decisions are being made. Then we are likely to more uniformly develop sustainable projects because all of these effects have already been taken. So that's the story of all innovation, right? So when I come in, and so in my world in construction, we have something called building information models, right? They're out there, the technology is there, but no one's implementing them because there isn't enough capacity out there. People don't know what to do, how to do it, etc. So there's a process of capacity building. There are a couple of arguments towards it. One is to say, while you're doing this, don't just sort of drop a bombshell and say, starting October 11th, 2018, all projects must do this, right? So don't drop that bombshell. Over a period of time, let's start indoctrinating people into this methodology, right? So let's have all whatever, training sessions, this, that, certification programs, all of this, right? So you sort of say, we will have this in place in 2021. Between now and then, we'll put out all kinds of material publicly available, we'll create training programs, and you guys get certified, right? The other option is to say, if this is what you mandate, the market will figure out, right? If this is, if I put this in, clearly there's a market for people who understand how to do this, right? And therefore, just market forces will ensure that people will train themselves on this, startup companies will evolve, etc., etc. So that is a problem, right? And you can solve, and it has to be a little bit of a mix of both, right? We have to set out certain guidelines, certain certification systems. I mean, how do I know that this company should do this environmental evaluation versus that company, right? Today, I can go to a chartered accountant or to a medical doctor because they've been certified by some larger authority, or even an engineer to get stamped to get a stamp on your drawings, you just can't go to anybody. So there's some kind of a certification process, right? Similarly, I need a certification process for this as well. So it will take time, right, for all of that to happen. But just like you have chartered accountants today, right, who are dealing with a certain set of things, you will either have chartered accountants of tomorrow or, I don't know, project chartered accountants or maybe a completely different designation that will be certified to do this, right, and that becomes a business opportunity. Right, chartered accountants generally make more money than engineers. So think about it, read about it.